All right. Hello, everyone. ETHTallinn day 2. It was excited. Woo! All right. Expect some more energy soon enough, right? The coffee's gonna hit. We're gonna be good. Yeah. Well, thank you so much, everyone, for joining us. Obviously, on this super fun weekend. Hopefully, you're having a good time. Maybe the first day of hacking. We have Santiago here. Devrel at Web3.js and part of ChainSafe, and he's going to be doing a quick workshop on wallets, contracts, Metamask, plugins, lots of Web3 fun stuff. Yeah, just really want to thank you all for being here. We're going to be running this workshop stage from now till about 1, then we'll have a break for about 2.5 hours, and then we'll be back around 3:30, and then should have a few more workshops from there as well. So. Yeah, enjoy breakfast, pastries, coffee, all that good stuff. Don't forget about the tea. For those that don't know, I'm part of Tea, and we're actually hopefully supporting Web3.js as a part of our grants program, which is really exciting. They're building it open source, and we'd love to support that. So, yeah, thanks Santiago, and everyone give it up for him. Thank you. Yeah, you can close that.
Hi everyone, nice to see you today. What we are going to do today, for you to have an idea, is we are going to deploy a smart contract. We are going to interact with this smart contract using scripts, and then we are going to interact with the smart contract using a front end and connect Metamask to interact with the contract. So I linked the slides to kind of have a reference for you to see the code, but I will just kind of start with the coding, and then you can refer to the slides later if you want to see the code. But the first thing that we have to do is just basically create a node project. So to create a node project, you can just go to any folder that you have. And then once you are in your code editor, we can run npm init -y. So that's how we create a node project. Then we will see that we have the package.json here. After we have the package.json, we need to install Web3.js just by typing npm install web3. Oh yeah, that's great. So now as you can see, we have Web3 here. So now we are kind of ready to go. The first thing that I'm going to do is to write a smart contract. I already wrote that in Remix. Who doesn't know what Remix is? Okay, perfect. So Remix is like a virtual environment that allows you to deploy, compile, and write smart contracts. It's really useful. When you come here to remix.ethereum.org, you will see this default workspace with the contracts, the scripts, all these things. In this case, I already wrote the contract, but then let me just go through it so you can get an idea of what is this contract doing. So basically, this is a smart contract. For those who don't know how to write smart contract, the first thing that you have to do is to put the license here. After that, we need to write the compiler version. In this case, I'm using 0.8.0, and then you need to create the smart contract object by typing the name of the contract. This contract, in this specific case, is just a simple counter contract. So it will have a main state variable, which is a number that I call counter. It will have a function that is called increase counter, that this will just increase the counter by 1. It will have a function that will retrieve the value of the current counter. So that's why you see the return counter here. And then, who doesn't know what a constructor is? Everyone know what is a constructor? Okay, perfect. And then in the constructor, we are setting up the starting number of the counter. So instead of starting in 0, we are going to choose like which number we want to start. So that's basically the smart contract that we have. So now let's do something. Let's deploy the smart contract into Sepolia. So you can come here to Solidity compiler, and you will see these two things. Okay, after you compile, I just have it in auto compile in case that you don't have it. So you just click in compile. We have these two things that we need to deploy the smart contract, the ABI and the bytecode. The ABI is basically an interface to be able to interact with the contract, and the bytecode is what will be deployed in blockchain. It's just a lot of zeros and let me just show you what that is. Just put bytecode.json. So this is basically the bytecode. We just need to put a 0x. So this is what will be deployed in the blockchain itself. We don't need to know what that is, but this is just a set of steps to be able to interact with the smart contract, and it will be deployed on the blockchain. So we have the bytecode. Now let's put the ABI here as well. So you can click here, remix. Okay, so now we have the ABI, the bytecode, and now let's create the scripts to deploy and interact with the contract. So the first thing that we have to do is to import the Web3 library. So we import the library by typing this. And then the second thing that we need to do, let's import also the bytecode, the ABI. So now we have the bytecode, the ABI. We need to initialize a provider. So a provider is basically an endpoint. Let me show you this in the slides. So we have this RPC provider that is here kind of in between. So the dApp will use Web3.js. Then the Web3.js will use the RPC endpoint to connect and talk to the blockchain. So every time they're using a transaction and you request a call, the RPC endpoint is kind of the middleman that will help you to connect to the blockchain. So if we want to find RPC endpoint, you can come to chainlist.org and you will find a lot of RPC endpoints. So just to show you really quick, if we use this one Ethereum mainnet, it's Llama RPC, and we initialize a provider like this, just type in new Web3, and then we put the RPC link here. So now we are kind of talking to the Ethereum mainnet. So let me just show you how that works. So if we just run, for example, look, if we just get this, get block number, and then this is just to kind of show you, like this doesn't really matter if you're following this or not. So we just run this, now index, and let's see what happens. So this is the current block number in the Ethereum mainnet. But now, if I change this to, let's say, Binance Smart Chain, and then we just change for, I don't know if Binance will work, I'll actually use Polygon, let's say. So if we use the Polygon here, and then I run the same thing, now you can see that the block number is different because now we are talking to the Polygon mainnet. So yeah, that's basically how you can interact with any blockchain. So now what we are going to do is to deploy the smart contract that we have. So to deploy the smart contract, we need to do some kind of steps that I will write here. We need to initialize a wallet, because when we deploy a contract, we need to have funds in the wallet that is deploying the contract. Then we need to initialize the contract. After we initialize the contract, we need to initialize a contract deployer, and then we can send the transaction. So to initialize the wallet, I have the code here as well in the slides. Yeah. So we need to create an account with a private key. So in this case, we will always need to use Web3.eth. This is kind of the main model that we have at Web3.js to interact with any EVM blockchain. Then we have .wallet.add, and then we can add a private key here. So for the private key, let me just come to Metamask. I will use this Zurich. Account details, show private key. Don't forget to never share your private key. This is only for testing purposes. This is the private key, but every string that we use in the blockchain needs to start with 0x. So if you don't see a 0x, you need to put a 0x there. We are talking about addresses or bytecode. So now what will happen is when we deploy the contract, we are using this ETHZurich wallet that I have here. So then we need to initialize the contract. So to initialize the contract, we need to type new web3.eth.contract. And then we need to send the ABI that we have here. To initialize the contract deployer, we just need to use the method deploy from this contract instance. So my contract.deploy. And then we need to send two main things, two main objects here. One will be data, and the other one will be the arguments. So the data is the data that we are deploying in the blockchain, and this data will be the bytecode that we have. And the arguments are the arguments for the constructor. So when we are deploying the smart contract, remember that the constructor is a function that only gets executed when we deploy the contract. So in this case, the constructor will receive a starting number. So let's start from, for example, from 77. Okay, so that means that that will be the starting number. And then to send the transaction to deploy this, we just need to type, let's save this into a variable, deployer. Okay, so we just need to send this deployer.send, and this is how we send transactions using Web3.js. We always type .send. And then here we need to specify the address that we are sending this transaction from. So in this case will be wallet.0.address. Let me actually show you what is this wallet before we send this. Index. So we can see that this wallet is an array which has one account. That account is the address, the private key, which is this one, and then it has some methods. But yeah, this is basically what we have inside the wallet. So that's why when I type here wallet, in the zero the slot dot address, we are kind of referencing to this address here, and then let's just run this, and hopefully it will work. When we send the transaction, this will return a transaction receipt, and then we can just print here the transaction contract deployed to, and then let's do transaction receipt dot options dot address. Yeah, so this is how we can get the address where this smart contract is deployed. So then let's run this again. Oh, sufficient funds. So let's see where I don't have funds here. Okay, so supposedly I need more funds, so let me just transfer funds from here. Oh, if you don't need funds, you can also let me know and I can send you some support aid. Oh, yeah, because I'm using Polygon. Oh, that makes sense. I was using Polygon and I'm not using the Sepolia provider. So that makes sense. I don't have funds in Polygon. Where is Sepolia? Okay. So Sepolia is the testnet for Ethereum, in case that you don't know. So I just changed the provider for the Sepolia one here. And then that will work. If we come to sepolia.vitresscan and we check this address, it's very we will see that, okay, we deploy the contract here. That 15 seconds ago, we just deployed a contract. We have this contract condition. So if we can come here to the contract, in case that you want to verify the contract, we just click on verify and publish. And this contract is basically this address that we have here as well. We can just copy this code to verify the contract. So a single file, 0.8, this is the compiler version that I have here. And then the license is the MIT one that I have here as well. Continue. Here we paste the Solidity code. And then I'm not a robot. Look, I was just trying these things. Entries. Okay. Okay, so now we're verifying the contract. So successfully verified, and then we can see that the smart contract is here. Then we have reading functions and writing functions. The reading functions are the get counter, and the writing functions are the increase counter. So if I come here and I say get counter, we can see that we have 77, because that's the starting number. Okay, so that's how we deploy a smart contract. Now, to make this kind of more fun, let's create a React app. we need to run npx create React app, and then let's just call it my app here. This will take a few seconds to create. And let's interact with the contract using Metamask for the front end. So I had any questions so far? Everything clear? Perfect. Let's just wait. So this is basically the code to deploy a smart contract. Let me write really quick how to interact with the contract to get a counter. So we just need to initialize the contract as well here. But the main difference is that now we need to specify an address because we deploy the contract. So we can come to this Sepolia scan, we copy the address, and now we have like the ABI and then the contract address that we are like talking to. And then we can, to interact with the contract, we can just run the contract instance, which is my contract, dot methods, dot, here we type the function name. In this case, the function that we are talking to is getCounter. So we just type getCounter dot call. And this is how we are making the call to retrieve the current counter. And then we can show that here, current counter, spots. And then if we run this, still. Yeah, we can see the 77 here. So this is how we can make the calls to the contract, and now I will show you how we can make we can increase the counter as well. But let's go to the React app. That would be more fun. So when you create the React app, you will have this folder. We just need to touch the app.js. This is what we are going to touch. So we can run npm start, and then you will see the React app by default, which is this. Perfect. And then as you can see, edit source app.js. So I'm going to delete all these things. So we don't have like this span here. Okay, and you can see that now we have nothing. So I'm going to create 3 buttons. One to connect the wallet, and then 2 more to get counter and increase counter. So I save this, and then you can see that we have the 3 buttons here: connect, increase counter, get counter. And then let's create 3 functions to do the same thing. Connect, just copy this, connect, get counter, and increase counter. And then to be able to kind of connect these functions with the buttons, what we need to do is here, we right click, and then we say connect, and then we do the same in the other 2. But here we have increase counter, and here we have get counter. Okay, perfect. So now we have 3 buttons. These buttons are kind of connecting to these functions. Just to show you that this is working, we can just print something in the console here. So when I click in connect, we can make sure that that's interacting with that function. You can come here, right click, is in inspection here, console, and then we will see that when I click in connect, we have this connecting. So we are printing in the console, and that's how we are making sure that that's kind of working. Okay, now we need to install the Web3 library here as well. So npm install Web3, and then we can import the library Web3 from Web3. Okay, perfect. What we need to do to be able to interact with Metamask is, instead of having like we did here, instead of having an RPC endpoint with this link, we need to use something called window.ethereum. So we'll have Web3 equal to new Web3 window.ethereum. So this is kind of the main difference. Let me just create 3 variables here: Web3, contract, and accounts. Perfect. So this is how we initialize the provider with the injected provider. Injected provider. then we can request the accounts. So to request the accounts, we can store this in a variable called accounts. I already create here. We need to type web3.eth.request accounts, and then you will see that now when I click in connect, this Metamask is popping up here to connect my accounts. So you can choose the account that you want to connect. So in this case, I'm connecting this ETH Zurich, and now my account is connected. Let me add a little thing here, which should be useful. Connected account. Okay. And then we need to use something called use state. That's more like for React and front end. Wallet and set wallet. What I'm going to do is just when we connect the wallet to show this in the front end here. So use state 0x, then import use state on React. So what I did is I want to show the wallet here that I connect. So when we request the accounts, we need to update front end by typing set wallet that I have here, and then we just send the accounts 0. And then let's see when I connect. This is stream. Let's see what happened. See where it's not connected. Set wallet. Oh, because I'm not showing it here. And then we need to show here the wallet. Yeah. So we use this set wallet to set the wallet, and this wallet to show the wallet in the front end. So yeah, now you can see that the wallet is connected. So when I click in connect, the wallet is here because we already connect that. Perfect. So now to interact with the contract, what we need to do is to create a contract instance as we did before. So new web3.eth.contract ABI and the contract address, which is here. Okay, we have the contract here. We need to import the ABI, so I will just copy paste this here. So we can import this, import ABI from ABI. Perfect. So now we are able to interact with this contract. So this is just initialize contract. Perfect. And now every time that we click in get counter, we are going to call this connect function just to make sure that we initialize the contract. Perfect. And now let's try to get the current counter from here. So to interact with the contract, same thing, contract.methods.getCounter.call. And then we can store this value in this kind of response here. Wait. And then let's create another state in the front end, which will be the counter, set counter, use state, and let's put 0. And now we have, I need to do that here. Current counter. Okay, so now we have this here. So if I click in get counter, we need to update front end here. So to update the front end, we just need to call this set counter as well. So set counter, and then we send this response, which will be the number that we get. And we just need to parse this as a string. And hopefully this will work. Perfect. So we connect the wallet. If I click in get counter, now we have the 77. So now let's write the function to increase the counter. So if we want to increase the counter, it will be basically the same thing here. Contract.methods.increaseCounter, because we just need to change the function name for the function that we have in the smart contract. So basically it has to be this one. Yeah, this one, increase counter. And then instead of a call, because we are sending a transaction, we just type send. Then we need to specify who is sending this transaction, so from, and then we just type accounts 0. Yeah, because this is the address that is connected to the Metamask. Then what we can do is that we can store we can actually update the counter. Await, get counter. So that means that when we send the transaction and this transaction is kind of confirmed, this will update the counter automatically. So let's save this. Let's come back here. Let's refresh the page. So I can connect the wallet, get the counter, and then increase the counter. Metamask pop up here. We confirm the transaction. And now when the transaction is done, hopefully we will see a 78 here.
I think you might want to use use effect.
Oh yeah, I didn't. That's true. Yeah, you're right. But I have the set counter here, so that should. Oh yeah. Oh, yeah, that's really work. It worked. So yeah.
Yeah.
Yeah. So that's basically how everything works. Now you know how to create this front end, how to connect MetaMask, how to interact with. There are only two types of functions in smart contract: writing functions and reading functions. The reading functions return a value, and the writing functions are updating any value. And now you know how to interact with both. And yeah, any questions? Everything is fine here. Perfect. Anyway, I will be around if you have any questions. You can come to me. Maybe it was a little bit fast, but yeah, I wanted to kind of fit everything into these 10 minutes. Perfect. So I think that's basically everything. I will share these slides as well on Twitter. Oh yeah, you can find us at ChainSafe, also at Web3.js. You can also text me on Telegram if you have any questions, Santiago DevRel. And yeah, you can just explore the Web3 plugins as well. So basically that's everything. Thanks so much.